Chapter 2.5 Resistance of ammeters, voltmeters, and power sources. Let's begin. Battery at low temperature. Ideal power supply and ammeter have zero resistance. There is no voltage drop across them. Ideal voltmeter has infinite resistance, so that it draws no current. The actual internal resistances of ammeter and voltmeter also affect the original currents and voltage distribution in the circuit. The internal resistance of a battery increases a lot at low temperature. It reduces the actual output voltage of the supply and hence reduces the current in the circuit. 1. Resistance of ammeters. Let's see how the internal resistance of ammeter may affect the current and voltage distribution in the circuit. Experiment 2F. Using an ammeter to measure current.
We will study the effect of internal resistance of an ammeter in measuring current. Connect a 1 ohm resistor in series with an ammeter, a 1.5 volt battery box and a switch. Close the switch. Read the current flowing through the resistor from the ammeter. Calculate the theoretical value of the current flowing through the resistor. Compare it with the experimental value. Are they the same?
Since ammeter is connected in series, the resistance of a practical ammeter increases the equivalent resistance of the circuit and hence reduces the current flow immediately when it is connected. The measured current or experimental current is the actual current flow when the ammeter is connected, but it is smaller than the original current flows in the circuit before the ammeter is connected. That reduction of measured current will be insignificant if the resistance of ammeter is very low. The typical resistances of ammeters are small. Small in the sense that they are much smaller than the resistance of the circuit. In other words, 1,000 ohms can still be small when the circuit resistance is more than a mega ohm. Example 15. Compare the accuracy of two ammeters. Theoretically, an ammeter of smaller resistance is likely to give a more accurate reading, and for this question, ammeter A, which has a smaller internal resistance. However, ammeter A also has a larger scale. The reading error of ammeter A is about 0.02A, and that of ammeter B is about 4 millia. In other words, the percentage error of the current measurement is smaller for ammeter B. Two. Resistance of voltmeters. Similarly, for voltmeter, its internal resistance also affects the currents and voltage distribution in the circuit. Experiment 2G. Using a voltmeter to measure voltage across resistors.
We will study the effect of internal resistance of a voltmeter in measuring voltage. First, connect two 100 kilo ohm resistors in series with a 3 volt battery box and a switch. Then, connect a voltmeter across one of the resistors. Close the switch. Read the voltage across this resistor from the voltmeter. Calculate the theoretical value of the voltage across the resistor. Compare it with the experimental value. Are they the same?
Since voltmeter is connected in parallel, the resistance of a practical voltmeter decreases the equivalent resistance of the circuit, and hence reduces the voltage across the circuit segment immediately when it is connected. And the reduction of measured voltage will be insignificant if the resistance of the voltmeter is very high. The typical internal resistances of voltmeters are large. Large in the sense that they are much larger than the resistance of the circuit. In other words, 1000 ohms can still be large when the circuit resistance is less than 1 ohm. Example 16. How voltmeters affect the measured reading. Theoretically, a voltmeter of larger resistance is likely to give a more accurate reading. And for this question, voltmeter B, which has a larger internal resistance. However, voltmeter B also has a larger scale. The reading error of voltmeter A is about 2 mV, and that of voltmeter B is 20 mV. In other words, the percentage error of the voltage measurement is smaller for voltmeter A. Do check point 10 on the next page.